Hey everyone, this is Vivek Bharata. First of all, a huge thank you for each and every one of you for supporting this channel over the past 1 year. It's been an amazing journey for sure, and I'm really grateful for all the love, encouragement, and feedback you have shared. If you are new here, welcome. This channel, Software Engineering with Vivek Bharata, is all about practical backend development, system design, microservices, and building some real world tools. As an event of this 1 year milestone, I have put together this one full video that combines all the episodes from Build Your Own Redis-Like Server from scratch with vanilla Node.js playlist into a single smooth experience. Hope you enjoyed. And for all the subscribers who joined in the last 1 year, in case you have missed this series, I would highly recommend to give it a try. And as always, happy learning. Hey everyone, we'll be starting a new series on Build Your Own Redis-Like Server purely written in vanilla Node.js, meaning we won't be using any external third-party packages for it and we'll completely rely on all the inbuilt modules. I have made the whole course into 8 chapters for now, and of course the first chapter is introduction and overview of the whole project, and that means this specific video. Moving on to the next chapter, that I'll cover on the basic setup that required for this whole project, meaning the development environment, and I'll give you a walkthrough on the TCP server, how the TCP server works. Coming to the Redis basics, we'll be actually connecting to our own Redis-like server via the actual Redis CLI, so that we can understand what exactly the type of data that is being transmitted from Redis CLI to our service, the TCP service. From there, I will be introducing into the Redis protocol. There is a structure how the messages will be sent across the client and server. So I'll giving you the proper briefing about it, and we need to parse it anyway. So I'll be going through that as well as a high level. And last, on the chapter 2, we'll be covering the very basic TDD initialization, so that for the rest of all the chapters that will be basically the base for it, so that we can keep building with all the test cases in place. Moving on to chapter 3, handling client connections. As in the previous chapter, we will be anyway covering the basics of the Redis protocol and all, but this time around we'll be basically close the whole loop of it, so that we can start building on the other the actual basic commands that we can provide: set, get, delete, and expire. Then on the chapter 4, we'll just extend with the basic commands with TTL, increment, and decrement operations. Then on the chapter 5, handling lists like left push, left pop, right pop, and list range. I'll be going more details when we actually go to that specific chapter. Then following chapter 6, adding data persistency. So till this point, like till chapter 5, we will be mostly juggling around the actual in-memory. Of course, Redis is like an in-memory database, but however, to make it more durable and persistent, somehow Redis actually also provides some of the different types of persistence. Basically, there are two. One I'll be covering on chapter 6, that is snapshots, how exactly the data persistence can be done with snapshots and all, and the more slightly advanced concept, that is append-only file, that covers on chapter 7. This is basically to provide the more durability onto the whole service and all. I'll be going more details when we go through these specific chapters, but we'll be covering two different data persistence that Redis provides out of the box. We'll be covering something similar on our own Redis-like server as well. On to the chapter 8, I'll be basically giving a full recap of all the things what we have done on our own Redis-like server, and also I basically covered only till list, but there are so many other data structures where Redis does provide out of the box. So this will basically give you a proper base for it, and you can exactly make all the operations and some more optimizations on the data persistency and how to handle concurrency and all. So I'll be giving you the proper roadmap from that point, how we can actually extend the whole server. Also, for each chapter I'll be maintaining a separate branch, and I'll be sharing all this information in the description, so that you can switch across the different chapters and you can basically start working from that specific point, or if you want to just make it as a revision, you can basically start from all the way from the beginning. Hey everyone, welcome back. In the second part of Build Your Own Redis-like Server purely in vanilla Node.js, we'll be starting out with covering the very basic setup required, like the simple VS Code and Node version, And also we'll be creating a basic server.js file where it is like a main core entry file for the whole server, and a test server file also just as a kickstart search, so that acts as a main base for it. And also a util logger file, so that we'll use the debug sort of the same debug logging thing with each module level and as such. So I'll give a walkthrough of that. And in the main basic server.js file we'll be creating a basic TCP server, and I'll walk you through by giving some telnet commands also and how the data gets processed. And also we'll be covering a very basic data transfer, how the data transfer going to happen. Like let's say I'll be having a redis CLI tool, right, the actual redis CLI, and we'll connect to our basic TCP server and understand how the data is being coming to our server. So on to the very basic VS code setup. If you can see, they are like just the WSL, because I'm using Windows for the tutorials, and I always prefer to work on Ubuntu. That's like actually a developer friendly, right? So that's pretty much on the VS code setup side. It's a very basic, just these three extensions installed, and there are like ESLint and normal GitHub IntelliCode Node.js based thing, nothing fancy. You can tweak this accordingly. And moving on to the Node version, we'll be using Node version, latest Node version 22. Let's get dive into the very basic file, that is server.js file. So let's begin. I will be giving you a proper walkthrough of all the lines of code, but not like writing each and every line, because it's kind of unnecessary time waste, because there are like few lines will be like self-explanatory, and I'll be covering all the very basic stuff anyway. Like if there are some new things that I feel that's really needed to be explained, like logger.js file, where I'll explain the how the debug functionality, like each module based logging, how that can be written basically with a vanilla JavaScript again, so that no need to rely on that. All these I'm emphasizing on a vanilla Node.js, because this will give you an opportunity to understand how the actual packages, like the third party packages, if you want to use, so that will help you to understand the actual crux of it, right? So overall, this project also, the aim is to not just, though we have so many client libraries, right, but the main crux is like, if you start building your own, and that too with a vanilla ecosystem like JavaScript, like purely for the browser, let's say, and for vanilla Node.js, the reason I'm telling it as vanilla Node.js is, um, we are writing on the Node.js because simple JavaScript can't run, so we need a runtime environment that is Node.js as the main standard, right? So that's how it is. Let's begin with the server.js file, and its first thing is, of course, will require the net module. And for now I'll just initiate the default values, the port and host, though yes, we can get it from the environment variables or from the config json and as such. But for the sake of the simplicity, in this specific part, I'll be just creating it as a normal constants, and I just created the um, server with net.create server method. Now we'll be having a listener on connection, which is like a main thing, right? Where for the new, so for the new every client, this connection handler will be triggered, and this is like an entry point for every data on. So we'll be having a data listener on the socket, which is like each, for each client we'll be having a socket object, right? And for that, for every data we'll be just converting that to a proper string, because the data would be here, it would be like a buffer. And from there I'm just writing it down as a response, just that having an prefix as res colon, and the actual string what we got from the client. That's pretty much in the data listener. For the end listener, for now we'll just use console log, and we'll just mention the client disconnected. Okay, that's it. Yeah, if you see, it's a very basic thing. I'm just using a net inbuilt package, creating a server, and actually having a listeners for the on connection. For every client we get this bootstrapped callback, and inside we'll be having some more actual listeners, that is on data, and also when the connection gets ended, right? Now we'll actually listen at a specific port and host, that is simply like server.listen, the port value and the host. That's it. And I'm printing at server running at so and so at the port. So now let's run this one. Node server.js. If you can see, server running at so and so 6379, and of course the port for the default Redis server is 6379, so I'm using the same thing over here. Clear? Open another terminal, and over here, give me a moment. Yeah, so now over here we'll just use telnet to connect to this server. As you can see, connected so and so. And here also actually we can have a log stating that okay, though so and so has been connected, but I'll just directly send some information to send some data to our server, right? So now let's say um, maybe from telnet, and as you can see, res colon the data what we are converting to the string, and we're just returning that as a response. Clear? Maybe a plus b plus a plus b. I hope this is clear now. So to give a summary, we just created a simple TCP server, right? And we just had a proper handlers, and from the telnet, as you guys can see, whatever the information we are passing, we are just returning that as is, just with the prefix of res colon, and you can see the same response. So yeah, that's pretty much on it. We'll begin with a first filtering out all the actual debug namespaces required. Namespaces as in the same modules like server, if you want to have any logs on the server page, or if you want to have any logs on the DB level persistence side, or any of the modules, right? So if you see here, debug namespaces, we are trying to get the array notation, and by default we are first getting from the debug, like if there are any values, of course with a comma separated if at all, else we'll just going it as star. So star self-explanatory again, print all the possible namespaces, no need to filter based on the namespace. So that's the main crux of it, and we're falling back to star, and and again we're splitting, and of course trimming also, and all the values will be over here debug namespaces as an array. Now we'll just create a simple function logger, and the first and the argument is namespace. So like whenever we're creating an instance of a logger, like let's say on the server.js, we'll mention that it is server namespace. And for the other things like persistence, we if you have a persistent.js file, then there will pass the namespace as persistence. So yeah, that's how it is. And now I'll just export this one as logger as is. Clear? So now if you see, for instance, let's say on the server.js file, we'll call this logger function with namespace as server. And by default, let's say if you're not passing any debug value, then this debug namespaces will be simply star. Okay, this is clear now, right? Now what we'll do, we'll actually will return, so this logger function will return like for now like four default log levels. That would be like info, warning, error, and debug, right? What we'll do, we'll create a log instance as like this, and log function will accept two arguments. One is like mode and the actual log message. Clear till now? Now we'll be returning an actual object for this logger function. Yeah, and here we'll be passing like four modes of what we are supporting. Let's begin with log, and log will be a function again, and here we'll just pass the message. Okay, and now we'll call the actual thingy, like the actual log inside the function. And here if you see, this is like a mode is log again. Don't get confused you over here, but I'll just give you a simple walkthrough. And if I just clone this one, so log, error, warning, and this would be, let's call it debug. Yeah, four log levels we are supporting as an example, like in our case. So oops, sorry, over here, and this would be error, this would be warn, debug. I hope this is clear now. So I think if you see here, the logger, it is accepting a namespace, and we are exporting that over here. Now if you see simply on the server.js, we'll require this logger file, and we'll call this logger function with the namespace of server. Now that specific log object will be having that returned value will be this object, right? And what you can do, let's say if you're just calling it as logger, then logger.log will actually call this message again inside. So if you that's the reason you're passing this as each level. I'll come to this thing. Now let's say if we just simply maybe call like this console.log.message off, we'll just pass the message. Clear? We are not using debug namespaces for now, but let's try to include this one over here, like const.logger dot require of logger, and we'll pass over here as server. Clear? Now this logger instance, if you see, will have these four levels, right? And with the namespace as server. Namespace here it will be server. Let's remove this one. Now let's say we'll just simply swap this one with logger.log server running at so and so. Now let's simply run npm start. As you can see, there wouldn't be any difference because we didn't change actually. Like we can actually add this one also. Maybe let's add something like this, and also oops, this, yeah. Now let's run this again. Got it? Log colon server. So now if you see, at this stage there isn't any much of a use case, right, for the logger.js file, like what is the need as such. Now instead of mode, maybe let's just swap this with space, namespace. Yeah, now let's run it again. See, the namespace is server running and at so and so. And if you see by simply looking at any of the log message, you know, okay, which module or which namespace this specific log message belongs to, instead of the generic console.log as such. Yeah, and now what we'll do, we'll actually filter with the exact logic, so that we'll consume the debug also. I'll give a walkthrough of that also. If that is not the case, star mean it basically need to log all the different namespaces based log messages. If not, if I just simply pass server, then it will only print all the log messages of the specific server namespace, and it should not print any of the other namespaces log messages. I hope that is clear. Now we'll actually construct a proper log message format, and if you see here, log message I'm constructing with the actual date, like the current date, to ISO string format, space, and what is the mode, so it will be like log, error, warning, or debug, and with a proper syntax, like which is wrapped with the square brackets, the namespace what it is being sent, and the actual message. I think this is clear now. I will just simply swap this one with log message. Now let's run it again. If you can see, with the proper ISO formatted date, time, the log, and the actual namespace, and the message of the. Now if you can see, this is being printed for any of the namespace irrespective of it, right? Now we'll start using this one to actually properly print the actual debug namespaces that needs to be logged, and we should skip all the other namespaces, right? So we'll wrap this line with the proper if condition, and that would be debug namespaces includes star, right? Oops, star, or debug namespaces includes namespace, like the given namespace, right? Clear? I hope this is clear. So what we're checking is, if the debug namespaces include star, right, then print whatever the namespace it is, right? If not, if that is not the case, let's me just wrap this properly. Okay, now let's say if I pass debug as persistence namespace only. Now in that case, the server dot instance, the namespace is server, right? And this if condition will be resulted as false, and we are not actually printing console.log or whatever the log level that is. I hope this is clear. I'll be passing down some examples so that you will be able to understand the crux of it. And if you see here, we're filtering irrespective of the log level also, but I it's always better for any error message we should print irrespective of the debug namespaces and all. So what we can do, we'll be using a simple if condition. So like if mode equals to error, right, we'll just print with the proper log message form, the same log message pattern, and in the error mode, and we're basically returning it early return, so that we are not skipping any of the error messages irrespective of the namespace what we are trying to provide over the debug environment, right? Now I'll just give you a simple walkthrough. Let's first do the npm start again, just to make sure that everything is working fine. Log server is running at so and so, and namespace is server. Clear, right? Okay, now let's open package.json file and we'll just pass the environment variable as maybe util, right? And I'll just save it and run it. So debug util server is already started, but as the namespace over here is server, but we explicitly told that print only for the logs which are part of the util namespace. Right now we don't have any util namespace logger instance, so it's not printing like you can't see. But what we can do, we'll just create another instance, right? Just for the understanding purpose, logger util for now, right? And I'll just pass it over here. Now what we'll do, we'll start using this logger util just for the sake of for you to understand clearly. Logger.log and maybe local client connected, right? Now let's start npm start debug is util. Now let's expand this one and let's connect to telnet. And if you can see util socket client connected. I hope it's clear. So whatever the namespace we pass, the logs will the actual logs filtering will happen, and it will print only that specific namespace logs. It won't print the other. Now we'll test the other one also, just for the sake, as we have this case, right? Irrespective of anything, we should actually print for irrespective of the passed namespace over here on the debug, we should make sure that all the error level log messages should be printed irrespective of the namespace. So for the sake over here, logon.error, what we'll do, we'll just print server error, server namespace error log message. Okay, start, and we'll maybe just connect again. So now if you can see, the actual message came even though this is like the server namespace, but we have that condition stating that we need to make sure that irrespective of the filtered debug namespaces, we should make sure that all the error messages of any namespace should be logged. And if you can clearly see, the server namespace is got printed, and this is actually passed down to std error. I hope this is all clear now. Now let's remove the temporary things what we just added over here, and let's start the server. And I think debug util, so let's revert this also, so we can just pass like this, or maybe let's remove, because anyway we added that as a anyway we added star as the default fallback option over here, right? So okay, so now let's start the server. When we got the server namespace log message, server running it so and so 6379. Now we'll actually connect to our service via the core Redis CLI tool itself, right? And make sure it's installed again. So if I just hit enter, now if you can see, it is connected Redis CLI to our thing. I think it's better to add a log, maybe client connected. I think it's fine for now. But yeah, if you can see now, let's pass something maybe from Redis CLI, enter. If you can see, protocol error got R as a reply type byte, but if you see, client is also disconnected because it got crashed. Now what we'll do, we'll just actually print what exactly we got it over here, so that it will help you to understand in which data format we are receiving the message. And also this will basically give you a better picture how to parse the Redis protocol. So that's a different topic that we'll be covering in the next video. Now let's print this one, rec data, right? Now npm start and Redis CLI. So we got, if you see here, we got *1, and if you understand clearly, there is a next line actually came, and we got $7. I'll get into the details, the actual RESP protocol and how the data will be transferred across the client and server. But for our sake, let's see *1. Then in the next line we got $7, and in the next line we got command, and there's an empty line also, right? Then the cursor came actually over here. Now what we'll do, we'll actually pass the bare basic commands like maybe set foo bar. Okay, if you see, Redis CLI crashed stating with an error, got R as a reply type byte. Okay, and if you see here, socket.write res request data. Okay, so it is not able to parse the actual value we are sending over here, that is like res colon the request data would be foo bar. Okay, now it is not working as expected because we are not returning the expected response structure that Redis CLI is expecting. Okay, now what we'll do, just for the sake of closing the loop to understand the pattern, I'll just pass the actual data that Redis CLI is expecting. This in-depth will definitely oops this in-depth will be definitely covering in the next video, like why exactly we need to send in this fashion and all. Stay with me, but for now let's try to close the loop. I started the server again, Redis CLI set foo okay. Now Redis CLI didn't crash, we got okay also, as the same what we passed it over here. But if you see, we got a different set of messages now. So *3, then $3, set $3 again, foo $3 again, bar. If you skip the number based anything which like a star or dollar, you would simply see that okay, set foo bar. That's exactly what we sent. So the pattern over here is simple, but I'll cover in the next video. But this is all. We just tried, we actually created a very basic TCP server, right? And we are trying to connect to this basic TCP server via the actual Redis CLI. And we have gone through the basic commands like set foo bar, and also the moment we just connect to the server, by default the Redis CLI on connection to the server, it is passing this statement also. Understood? I hope this is clear till now. That's all for the functional side of the case for the part 2 of this course. I'll just revert this to, maybe we can just keep as is for now, and I'll just have the commented file log also for you, because I'll be pushing all these changes to chapter 2 branch. Okay, now we'll create a very basic server.test.js file, and I'll give you a walkthrough of it also. Alright, so starting with a very basic server.ts file, I'll be having, so I'm not writing each line by line for the test cases from now on. I'll be explaining all the details, but just to save time, because I'm not telling that the tests are very not that important. No, it is really important, and for the entire course, we'll actually rely on the test cases to make it robust. Yeah. Now to begin with, we are using net. I'll just go through because we need to connect to the actual server, right? So we'll be using the same net module. And for the test cases also, we are not relying on any third-party packages. Node version 22 does support the test interfaces and all. I'll be giving a walkthrough. So if you see here, we have a node assert, again the inbuilt, so we can use for all the assertions, and before, after, and the very basic test instance like the test function also, so that we can have a many different test cases by using this test function. Now moving on to the next block, I'm creating a Redis client as a, maybe we can call it as a global in this specific instance, and having a function connect to Redis which is returning a promise, and we are trying to connect to the local, the same host, and the port is 6079. If it is all okay, resolve, and if there is an error, reject. Simple. Connect to Redis function, it will make sure it will connect to the default port 6079. Clear? Now we'll be having a very basic before and after blocks. If you see before, so for the entire test suite, we'll first try to connect to Redis as the main thing, and at the very end, if the Redis client exists and if it is not destroyed, we'll close the connection. Simple. Before and after. Now I'll be having a um, placeholder function on error. I'll come to this specific line very soon, like this specific block. Now let's jump on to the main command, send command. This will make sure that for every test case, uh, it will write that message, like it will write as in like passing that message to the our server. And for the very first, like once for the first occurrence of the data event, will consume the data and will remove the listener like on error. The reason is, for if you don't remove this listener for the very first time, like for every instance of the data, it the listeners keeps by building up and will reach the max listeners events and all. So that's why I'm using a common placeholder function, and if there are any errors or as such, I'll just reject that, and basically the whole loop gets done at that instance. So I'm making sure that once we consume the data, like for the like for every call, like for every instance, once we consume the data, I'm just removing the listener also, which is not required, and we are removing, but the actual listener hook is happening at the last line. I hope this is clear. It will be clear the moment I'll actually start using this send command and the on error also. So let's actually write the very basic test case, right? Should set and get a value. Simple. And the same thing what we did over here with the actual Redis CLI, set foo bar. The same command, set foo bar, and assert strict equal the set response what we get from the server. I'm just comparing that whether that is exactly equal to okay or not. And again this send command get foo, we actually didn't started writing this command support, but I have written here so that we'll explicitly fail this case and we'll close the loop in the next video, so that this test case also gets passed. Simple. Don't worry about these things will be covering in the next video, but for the sake of it, I'm just trying to close the loop, so that not as a success loop but having it as a placeholder, so that in the next video we'll make this test case also gets passed. Okay, I hope this is clear now. I'll just give a proper summary. So no third party modules, all are like internal net instance, assert and the test, before, after and test, and connect to Redis. So we are just making sure that this is being connected only for the very ones for the specific test case, test file at least, and after it's like trying to close the connection at the very end of the test case. And the send command will make sure that we are sending a command and we'll be having a listeners only once for the data and error for that specific write command. And once if the data we've received is processed like properly, then we need to remove the listener. So as I'm attaching a listener over here, we should make sure that it is being removed. We won't get this max listeners error at this stage, but down the line we'll be having a lot of test cases and we will get that warning message stating that okay, set max listeners has been like the max listeners has been reached, like the default is 10 I guess. So just to prevent that, and also it's a very good practice because as we are attaching this, and this is happening only for each this specific send command. So at least in our case, for this simple test case, right, one single test case, we are passing two send commands, and indirectly inside it will be having two error handlers, though it's once, but we'll be actually hooking two functions at least for this one specific test case, and it keeps building. So we should make sure that the moment we receive the data for that specific send command, we should remove the listener also, and it's very good practice. Clear? Okay, now what we'll do, we'll just start the server over here, and oops, node server.test.js. Okay, so we got two commands, set foo bar and get foo also, and this will fail. As you can see, it is expecting this one as the value, because initially we first set foo bar, so the bar value will be stored in this foo key, but we didn't close the loop of the actual functionality, right? So we are expecting the value as bar, but as you can see in the server.js file, irrespective of any command we pass, we are just passing okay, right? We are just sending the response as okay. So actually is okay, but the expected is this one for the last assertion. Like we have two assertions, so this is all passed. Like if you see over here, test one pass 0, I mean it is treating it as one test case, but one assertion is already done. Maybe if I can just simply comment this out, and if I run the file again, pass it. Clear? That's it for second part of the build your own Redis-like server. If you have any doubts, feel free to comment down in the video. I'll answer and respond accordingly. And if you see there is any other improvement areas or any suggestions, feel free to drop the comment again. We will combinedly make it more robust and all. I'll make sure all the changes what we have done so far will be pushed to the chapter 2 branch. All right. Yeah, that's it. Hello everyone, welcome back to Build Your Own Redis-Like Server. In this video, we'll be covering chapter 3, that would be handling client connections, set, get, delete, and expire. So these four are very basic fundamental operations that we can build to start with. And also this will give you an opportunity to understand how the REST protocol is and all that stuff. So let's get started. Alright, to begin with, let's start the server again. Npm start and it's listening. Let's try to connect via Redis CLI, which is an actual CLI tool from the Redis itself that will be connecting to our own server. So yeah, it is connected and looks like everything is working fine. So this is like a standard we need to send as a response for as a default, okay, like if it's all okay with the command what you have sent. I'll go through that. So I think for now everything looks good and the loop is also closed. To begin with, we'll start with the RESP protocol, that is like a text-based protocol known as RESP, Redis Serialization Protocol, which is designed to be efficient and easy to parse. So I'll be sharing some examples starting with the this one. So plus okay slash r slash n. This is nothing but when we are trying to send okay, the message has been processed and accepted. So somehow to the Redis CLI we should inform that the thing is all okay, right? So similar to the HTTP 200 status code, you can treat this as plus okay slash r slash n is like a valid case, yeah, and it's all processed and successful. Let's say if there is some error, right, if I pass some vague commands and all, we should send with the proper error status codes and also this is how it is. So minus err space unknown command slash r slash n. All this information you can go through the official official Redis documentation where they given all the in detail thing. Something exactly as per the REST protocol we can try to cover down the line for our course, right? And numeric replies also. So 1000 slash r slash n. Starting with strings and arrays, things would be a bit slightly complex, but once you get the actual heck of it, like how the serialization is working and the deserialization, that's very easy to crack. So I'll just give you the example of strings over here. Let's say, so it is like $6, right? That means like the number represents the length of the string. So whatever the number which is coming after the dollar is like the following, what are the characters or the bytes will get after this specific so and so. Ignore slash r slash n for now, only for now. Yeah, so 6 represents the length of the characters. So if it is Vivek, then that would be $5 slash r slash n Vivek again slash r slash n. So for every set of bytes, the separator in this whole RESP protocol is purely slash r slash n. That's kind of a next line. Okay, that's why if you see here, the moment Redis here like connects, we are getting literally like 4 new lines, right? So star n, then $7, then the command, and again at the end. If you see the cursor, the last cursor over here, so it's like 4 new lines. Clear? I hope it is clear. So if it is a string, like if it's like a proper string, we just get with the length of the string slash r slash n as a separator. We can treat that, and the actual length foo bar, and again at the end is like slash r slash n. Same thing applies for any of the thing, any of the response. Okay, now slightly an extension. So this is like sending for one single string, right? Now if you want to send an array of strings, so that would be the starting character would be star, and it will tell you the number of strings in the array. So here if you see 3, that means like total we have 3 strings in this array, and the same pattern follows. So after this there should be a separator, so slash r slash n $3. So straightforward, three characters would be coming as a following, and again $3. So total 3, right? So first string length is 3, and after the first string is done, then the following string value is again 3, in this case foo, right? So foo foo 3. Then the following again $3, that is bar. I think the example is kind of confusing, but you got the point, right? So if it is beginning with this star, you can treat that as an array, and array length will give you the following number. And for each string length is the same pattern what we follow over here. I hope that's clear. That's pretty much it. On high level, like this is the very fundamentals we needed. If you know these things, like how to pass the information, I think we are good to go and follow the same RESP protocol. Yeah. So again, this is like a more breakdown of the whole explanation. So let's break down the set command. So the actual set command would be simply, let's write it down. So let's set foo bar. If you see here, *3, that means like we have total 3 strings in the array, and the following $3 will give you the length of the first string in the array. So that would be $3 bulk of string of length 3, then set 3 characters, right? And the following number again tells you the next set of string length, that would be foo, and in that case that is foo. Then foo bar. Let's use some other example. I think this is kind of confusing. Let's say Vivek Bharata. And if you see here, again the same, because 3 strings, right? Set, then Vivek, then Bharata. So 3 strings in the array. So 3. And if you see set, which is always, it will be consistent enough, right? Set get something similar. So that is 3. Then if you see Vivek, so the actual length is 5 over here. Bharata 8. Now let's start processing the command. So here, irrespective, we're just logging over here, right? We are not actually processing and building our own stuff, right? So to begin with, we'll start with the very basic command set, and we'll try to close the whole loop by passing the command, executing the command, and also saving the information for now as in memory. Okay, let's begin. To start with, we'll create a code.js file, which self-explanatory, which will hold all the necessary information. So first thing I would be creating would be like simply parse command. Let's use for now as data, and let's export this also. We'll be exporting more, but for now let's use something like this. Okay, it's exported. Now on the server dot, let's close these things. So on the server.js, let's just simply pass it down. That would be parse command. It gets automatically imported, and oops, we can pass as is. So for now, to close the loop, we can keep the response as is. For now, we'll close the whole loop by successfully completing the whole set operation. Okay, so parse command. Now let's go back to the parse command. First thing is, anyway we needed to split the information, right? So let's call lines, because the separator is /r/n. So just to begin with, data dot toString, right? Then let's split, oops, split with /r/n, and let's print this out. Just for now, I think we can use logger also, and let's call this score. Then logger dot, you can see log, and yeah, let's print these lines for now. Okay, and we can all actually pass watch over here, so that it keeps refreshing automatically. We don't need to stop and start the server. uh, you could ignore the warning for now. Watch mode is an experimental feature, and of course, yeah, cool. All right, so let's begin by passing the same command. Let's use foobar. Okay, I think we are doing over here multiple times like logging. Let's, I think we can just simply remove these lines, right? Okay, so code.js, you can see *3 $3 set $3 foo again $3 bar. Let's change this. I think let's maintain different values at least. So set 3, So three actually five. Okay. And just to be on safe side, let's trim it down also. Yeah. Okay. I hope this is self-explanatory. And if you see the server started, I mean, whenever you save, the watch thing is working and it started. So let me just see set 1 3. Uh, okay, so we are aligned. Now lines we are getting properly. Now if you see here, in most of the commands, third element in the array, that is in the lines array, third element would be the command. So we can just extract that also, right? So let's just use that constant command lines of 2, and to always make it consistent and easy to parse, let's use something like this, and also just print it over here, and let's pass it again. Exactly happened, did we pass the value? Yeah, lines of 2 uppercase, and we are printing the command as well. Oh yeah, this is, let's do like this one up. Remember, the log is exactly the console log, and you need to pass it as the first argument only. We can't, I mean, we can do that, but you got the crux, right? So let's add a concatenate for now, and let's pass it again. Yeah, you can see set over here. Now let's just have it as a separate line, just to isolate logger.log command. Okay, let's call this again. Set is the actual command, and now the fun part starts. If you see after set, there will be a value again, right? And we keep getting the argument. So let's see set 1 3, right? Let's call maybe set 1 3, and there could be some other extra options also. So let's call after the command whatever the values we get it, let's call those as the arguments, right? So how to extract arguments, it should be straightforward. So let's see, after the actual command that is at index 2, then from starting from fourth index, right? Starting from fourth index, you can skip alternate indexes, and you can basically combine all the arcs. So that simple specific line would be this one. So lines of slice starting index is 4, and filter based on the index again alternate, right? So I just use index and percentile too. I think it's self-explanatory. So let's add this arcs also, and let's remove this. Clear? Set 1 3, perfect. That's all. So let's just simply return these. So we have consumed the data, and we passed it with a proper command, identifying the command, and also passed all the arguments from that specific command with the space separated. But again, the actual values would be in the same RESP protocol, right? So we passed it accordingly. Now we have both command and args. Clear? Now head back to server.js, and let's use these also over here. Command and oops, args. Okay, I think no need to print these also for now. So.js, and we have this one. Now once we have this information, let's try to execute also. How we can do, we'll use the same code.js and create another function. Okay, it's not being used, but for now that's fine. So let's say maybe it's called execute command. Yeah, and okay, so execute command also can be over here, and we can basically just use the same thing, command and args. Okay, now what we can do, we'll just assuming that the execute command would give you a response. So constant response execute command and args. All right, so we can send the response as is. We might face some issues. Let's say the pass command doesn't have any valid command. Let's say the execute command inside the definition, we'll be using a switch case, or we could use different, because we will end up we'll end up supporting so many other commands, right? So okay, now what we can do in the server.js, let's create a response over here, right? And let's try to wrap this up, and we'll send the generic response all in all. So let's call it response. And okay, sorry, oops, instead of returning, yeah, we actually need to write to the socket, and that would be response. Okay, so in the worst case, like if we are not able to send the process the information, we need to basically send this one. Yeah, so let's copy this response. Okay, and we can actually better to, let's add a logger also. All right, so over here we'll just use these things. Okay, can, yeah, clear. Now let's try to complete the whole execute command also. And to begin with, let's just add an info over here, loggle.log received. Maybe we can just use, okay. We'll just log as is for now, right? Just as logs again. Okay, command and args. Now, if you think on a big picture, we need to support a lot of commands, right? Let me just open this one. So if you see set, get, delete, expire, ttl, increment, decrement, all the 5 operations on list, right? So there's like more than close to 10, right? More than 10. So what we can do, instead of using a switch cases and all that stuff, we can actually have a constant with with an object with each command as a field and the function definition as a value. So what we can do, we can use something like command handlers. Okay, simple object, and here it would be like get function definition. That's it. So and also over here, now what we can do is constant. We'll first see if there is a uh, valid command or not. Okay, so accordingly we will process, and if not, then we can just go back to the, like we can just simply return the fallback unknown handler thingy. So handler, and again command handlers of command, we'll just pass the command as is, and command will be in uppercase always. So and now we'll just as a header handling, if handler is not available, we can send this one, like the error thingy. Let me just quickly write it down. let's copy let's copy quickly, yeah. So this one, code.js. Okay, just in case if the handler is not available. If it is available, then we can just simply call handler of arg. So we'll just pass the args accordingly, and each function, each method, each command will have that specific definition of it. And if you see here, let me just quickly do redis CLI. So it got failed, and if you see invalid arg type and okay, received command. So now if you see on the server.js, we are processing it as is, right? And there could be an error, I think so. Received command, oh, received command is from our part, and invalid archetype writable. I think it's not able to process it. The reason could be this one, of course. This is should we'll just need to override this one, right? Uh, Connect again, received command, yeah. So the loop didn't close properly, I guess. Let me just reiterate again. So received command. So let's close these readmes. Package not just not required. So on the core, handler, command handlers. Let's add this command also, right? Okay, and we can just, in fact we can just send plus okay slash r slash n, simple. So now let's see, this command should be coming over here, and let's, okay, looks like everything is working fine. Just to be make sure everything is working as expected, you can just add a temporary log over here. Okay, and let's get it, and yeah, okay, clear. So we close the loop, like at least the base for it, so that in the code.js we are calling this execute command, and inside we have, so down the line we'll be having all the command handlers over here. We'll first see whether the handler is valid or not. If not, we'll just fall back to the error unknown command, and it will be passed down all this. If you want to cross check this one, let's say we can do test 1 2. You can see the it also passed on the Redis CLI also, because we are sending in a correct exact how the Redis CLI is expecting, and we can just use it accordingly. Okay, so test is not a valid command, and also, yeah, now in our case we close the loop properly, because this handler is not available, and it just goes here, and that response will be captured over here, and it will be sent here. Clear? All right, now we'll actually start saving the value. So get set and all. Oops, I think this should be set for now to begin with. Yeah, okay. So for the set, let's say um, we need to store this values in memory, right? So for now we can keep in memory as an, of course, a pure object we can do, right? So we can just use store as a pure object. Expiration times, I'll just get into that, because in this video we will be covering expire also. So we will set, okay, this key should be expired in so and so, right? So we'll just maintain two objects for now, and is expired, we are just checking whether this key, right, if it is part of the expiration times, and if it is there, then the value will be saying the when this thing should be expired, right? So we are just checking if the value of what we stored over here for that specific key is less than the current time, then it's purely expired. It does mean that it's expired, so it just returns the boolean accordingly. All right, this check expiry will be called every time when we use the get command, right? We'll first see whether the key is valid or not, and if it is there in the memory, and also in the expiration times if it is set, then we'll see is it really expired. If it is expired, then we ideally need to remove those keys, right, because it's expired. And also we'll just say, okay, check expiry if it is expired or not, so it is true. Else, if it is not, even in this case, either it's not in the expiration times, so this thing anyway will be false, and we'll just say false, so it will just return false, which means like it's not expired. Let's complete set command, so that it will give you the clear picture how the in memory it's a simple object saving key value, but still from once we complete this one, we can just literally copy paste, and we'll try to complete the other commands also. So if you look at the execute command, once we get this one, we are just passing the array args as is to the handler, so that would be coming over here, and for the set args, right? So the first thing is, we'll first validate for set command, at least we definitely need a key and a value, right? So let's set foo bar, right, bar 1, let's say. So there is an error over here, I think received undefined. Okay, let's see. Set command handlers, this also received undefined. Okay, let's save this again, and it started. Maybe we'll just create this, and let's call it set foo bar. Okay, so the server is crashing. Let's try to debug. Received set foo bar, then, oh yeah, I think we are not returning anything. In what the chunk argument must be of type string or an instance, of course. So over here we are sending, and the response, we are not returning anything, so it would be undefined. So it's not a valid thingy, received undefined. Yeah. So to close the loop, maybe we'll just let's leave it. Let's try to close the whole loop first. So for the set command, we should be having definitely key and a value, right? And we are checking here the args length, and the first the first element in the args would be the key, and second element will be value. So what I'm doing, I'm just, this is a store object, right? Simply it's a JavaScript object, as simple as it is. So store of key, and you're passing the value. And if you see here, type also we are mentioning. The reason, if you look at the other operations will be performing down the line, there are so many other operations. So delete, expire, and TTL is there, and increment and decrement. So let's say if you're saving a key with a equals to 10, you could use increment and decrement to alter the integers or the numbers, right? And lpush, rpush, these are like a list, right? So in order to save that data type also, and also the Redis itself in general has so many data structures inbuilt, so it's better to save the type also. So in our case it will be string. Okay, then once we process it, we are just sending okay, all processed and fine. So let's save this at this stage by returning plus okay and R, and let's connect this to again, then set foo bar. Okay, we got a response as okay over here. Clear? Now we can complete the get command function also. If you see, just to save time, not to write each line by line, because from here things, because the main heavy lifting is done, like parsing the command. I see at this stage, um, parsing command is kind of a tricky to understand, and I mean if you get the actual crux of it, it's easy. But yeah, so if you see here, get command, what exactly get command does, so we set over here as set foo bar, right? When you call, when you pass a command as a get, and the value like the key is foo, then we should return bar. That's it, right? So what we'll do, the same thing as a validation. For get command, at least I need a key, right? At least not, that's the only thing we need, right? So we're just checking args.length is 1 or not, or at least greater than 1 or not. Then if that is not the case, so what we are sending, error, wrong number of arguments for get command. Okay, let's try to call that one. So I'll just use get, and immediately if you see here, error, wrong number of arguments for get command. Okay, now after that, once the validation is done, I'm getting the key again, the same structure wise, and I'm first checking the check expiry. Okay, if expired, if it is expired, -1, so it's like okay, not found or nil sort of thing. Yeah, if the key is not there, right, and if the key is there but still the type is not string, then get command doesn't work, because for all the other types of data types, for all the other data types, we can't just retrieve it and just send it, because for at least for the list, it's like a big range, big chunk of elements will be there, right? It's not just a single string value. So we are just validating this also. So either of these condition match, then we are just sending okay, it's an invalid, or I mean not as an invalid, so it's -1, so it's like a not found sort of thing. Yeah, and if this is all okay, right, and even check expiry also, I'll just get back to that like once we complete the expire command support. But for now, we can, let's go for the positive scenarios, right? And value, we are just good, because here if you see, it's not a flat key value type. Key is fine, like the key is the actual key what we are setting, but the value would be an object, and inside we are storing the type. So once we get this thingy, store of key of value. Clear? So this value we are passing over here. So the response here is kind of tricky. Remember the RESP protocol. If you see here, if you needed to return bar, right, then we need to send in a proper fashion. That would be $3/r/n, then bar, then again /r/n. So that's how it would be, right? So now if you see here, the same thing. So value, let's say the value is Vivek, right? So Vivek.length, that would be 5. So $of 5 here, /r/n, then the actual value, that would be Vivek. Simple. Okay, let's save this. Server restarted now. So if you observe, for every save, as we added the watch option, right, it is restarting the server. If you see that the timestamp will keep changing, right? Okay, so make sure when you're testing it out in your local, the moment you save it, the already in memory stored values will be off. So let's say, now let's call it set1, set11, right? It is saved. So now if I call, let's don't call anything, then it's like if you don't pass any arguments, we are just getting that error. That's kind of a validation we have for the get command. Now if I do get one, there you go. Okay, this is again confusing. Let's call it set foo bar. Okay, now if I call get foo, getting bar, so we are completed. Like the main data flow for set and get is completed. The same thing applies for the other set of commands. Now let's just try to close the loop and support del also. So if you see for the del, something similar. First we'll see, because for the del also, like delete, right, we need to pass the key. So that's the validation over here. And once you get the key value, we are first checking whether we do already have that key or not. Okay, if it is there, then deleting from here and deleting from expiration times, and we are acknowledging, stating that okay, it is deleted. So for the delete, if it is successful delete, the response we just pass it as :1. Okay, if it is not found, we'll just pass it as :0. Clear? So let's save this. Now let's do again, let's call, because we saved the we saved this code.js and server restarted. So at this stage the store value will be empty, right? So even now if you call del foo, integer is 0 because it didn't even find. So let's set the value, set foo bar. Okay, now get foo just to verify. Clear? Now if I do del foo, I got integer 1. Now if I try to get access again, I get nil. Simple. I hope it's all clear now. So -1 will resolve that to nil. Okay, yeah, we close the loop. So the bare minimum functions, like the fundamental commands, are almost done, right? Perfect. Now moving on to the final command we are supporting in this video, that would be expire. Expire also similar, just that it will accept the other value, like after how many seconds the value should be expired. I'll just give a walkthrough. So if you see, the first argument is key and how many seconds, right? So first we are checking directly straight away. If it is not there in the store, then there is no point in expiring and all, because it doesn't make sense. It's not even in there. So we'll just send the value as 0. So if you see the pattern, overall for most of the commands, that the key what we're trying to alter or delete, update or delete, let's say, if it is not there, we are sending it as start :0, right? And in this case also, when you are trying to expire a key, if it is not found, we're just sending 0, right? :0 again. Then for this specific key, in the expiration times, remember we have we are maintaining a separate object to store the expiration times, and we are using these things to verify when we calling get command. Okay, so once we get this one, so expiration time so and so, current time plus seconds into 1000, just to store in milliseconds. That's it. So let's save it again, time updated. So now let's call set foo bar. Okay, now if I call get foo, still getting. Now what I'll do, expire foo in seconds. Let's do 5 seconds. So I'll just quickly use get foo. I can still get the value. All right, let's see now. Okay, get foo nil, because after 5 seconds, if you look at the pattern over here, when you're calling get, right, on the get side, on the get handler, you're first checking the expiry. So in the check expiry again, if it is expired or not, right? If it is expired, right, we are just deleting from the store and also from the expiration times. So for every get query, we are first checking whether the key is in that expiration times, and if it is there, then you are validating whether that time is less than the current time. If that's the case, then we can just simply remove and we can just send -1. That would be like a nil. Okay, yeah, that's it. So on the functional side, that's pretty much it. Now let's jump on to the test cases, because manually we tested all the functionality on the commands what we are supporting, set, get, delete, and expire. Right now, what we can do, we'll just focus on the test cases to close the loop, so that we can rely on the test cases to test it out, and down the line for almost every command what we are trying to support in the next set of videos, we'll be going with these test cases as the main reliability for to assess the whole server. Yeah, so server.test. Let's get exit from Redis CLI on the second terminal, and let's run npm run test. Let me just see what we configured over here. Okay, looks like we don't even have this command, so let's just add it right away. And that would be as simple as node server.test.js. That's it. Okay, let's clear this out. Npm run test. Let me just expand now, because this is all is required. um Looks like some case is failing, so let's try to fix that accordingly. So server.test.js, redis client, unknown command. Oh yeah, of course, if you see the send command, we are just passing it as set foo bar, right? And if you clearly notice, the same command, we are just sending it as write. So that write is nothing but the redis CLI way of doing stuff, like set foo bar. Okay, we are printing over here like that. We need to send in this pattern for this write command. That's kind of a manual thing, and it's a tedious job to assess and see. So what we can do, we can just simply create a utils .js for now, and I will be dumping the code right away. I will be explaining that. So it's easy. So build redis command, right? So what we are doing, let's say in our case it is set foo bar. So I'm splitting with space, and I'll get an array of 3 elements each. Like first element would be set, second foo, third is bar. Now, if you recollect the RESP protocol, this is exactly similar as we are passing three strings. Three strings as in it's an array, right? So if you see here, star 3 is the number, like the length of the array, right? So what I'm doing, I'm trying to build the whole command, keep appending, and just returning the command that we need to send, like the actual RESP supported string. So now what we do, first to begin with, if you see, let me just open, if I can do it in the side. Okay, so first thing, star to begin with, and the length of the commands. So that sorry, so that would be args.length. Okay, slash r slash n following. So we completed till this point. Now for each argument, right? For each argument, so this argument is nothing but the string, right? So the strings, the pattern is we should start with the dollar, and for the arrays that is star, right? So dollar dollar, don't get confused, this one, this is like a template string, right? So this dollar is the actual dollar over here, and this is like a template string variable. So arg dot length, so in our case foo value, foo of length, that would be 3. So $3, then again slash r slash n, and the bar, oh sorry, here the like the actual length, then here in this case the actual value of it. So length over here, slash r slash n, then the value, and you keep iterating, because the separator is again slash r slash n at the end, basically the next line. Okay, clear. You could try it out, but it's simple, so I'll just rephrase. So for any commands, the number of space separated strings, that would be the star 3, and following $3, sorry, dollar, the length of the string, and how many number of arguments, we just construct that and keep appending, and we'll just return that as a command. I hope that is clear. So on the command side, instead of writing send command something like this, we will just use build redis command, and let's pass this over here itself. Okay, else I think we, instead of calling this function inside over here, we'll just use it in the send command, because for the send command anyway we need to keep using this, right? So yeah, build redis command, that's it. I think this should work. So let's clear out the console. Npm run test. Yep, all good. So test successful, should set and get. Let me just go through it. So what we are doing, set foo bar, right? And in the set response, we are expecting whether it's all acknowledged, and immediately we are calling get command also, and you're validating that. And you, this is also, I think, should be self-explanatory again. Bar, right? So the server v will send in this fashion: $3 slash r slash n bar and slash r slash n. Clear? If you want me to look at over here, get, right? Once you get the value, dollar value dot length slash r slash n and the actual value. Clear? That's it. So should set get value, we have this test case. Let me just fill in with the other blocks of test cases. I'll just give a walkthrough of it, of those as well quickly. um, so for a non-existent key, this is the test case. So should return $-1 for a non-existent key. So if you see here, so the test suite, the whole setup is in one terminal we are running a server, and here if you see on that server test, we are just connecting to the same server. Okay, that's it. So luckily at this stage it's all in memory, so if you want to refresh the in memory, if you want to rerun the test cases, if you just simply save the file, the server restarts, the whole in memory will be empty object again, and you can run the cases, the test cases clearly. Okay, so let's resume. Should return $1 for a non-existent key. So here the key is foo1, not just the foo, and we'll get -1. Okay, let's run this again, right? Alright, so let's do the delete also. I'll just fill in the block over here. So should delete a key. So what I'm trying to do is I'm setting foo del as a key and pour bar as a value. Okay, looks odd the value, but okay, for the sake of testing that should be fine. So first I'm setting a value pour bar for foo del key. Okay, now I'm deleting by simply calling del the actual key, del response :1 if it is valid. So we are basically asserting these things over here. Then once we deleted, we are trying to call the same thing, get foodle, and we're just checking whether we are getting nil or not. -1 is nothing but nil. Okay, let's run the test case again. Total 3 tests passed, and if you can see, we are receiving del food, the same commands. What now, without storing this one, if you do rerun the tests, okay, in this case it is passing, but few of the cases there will be, like, if you are trying to delete and expire and all, if you just do the same test case without refreshing, at least at this stage it's in memory, right? So it might corrupt the existing data, or even the test cases would fail. Now let's complete the video by having the last chunk of test cases. That one would be simply expire. Okay, should expire a key, right? Set foo exp bar. Okay, so first we are setting a key of foo exp, and the value is like exp bar, and I'm setting that to 1 second. Okay, then if you see here, waiting for 1.1, so it is like a simple promise based thing. That's why we have an async over here. And after 1.1 second, after, not exactly as 1.1, because set time mode doesn't work like that. Once it's done, so after 1.1 second, we'll just try to get foo, and we should get the same nil, -1. Okay, let's run again. So if you see, there is a delay, right? 1.1, and this 0 to milliseconds is literally for to run the whole test case. 4 tests pass. Let's add the very last chunk. This is like just to send some wake command, right? Instead of the all unknown or something unknown test. And if you see, should handle unknown commands gracefully without crashing. So I'm just passing the command as unknown itself. You can try anything, but just for this one. So then we'll say error unknown command. Okay, if it's confusing, let me just use Vivek test. Okay, now if I run test 5, should handle unknown command crash. So it is returning unknown command, error unknown command. Okay, let's just use it. Oops, unknown. Clear? That's pretty much it. So I'll just give a summary of the whole thing. We started creating. We created a new file code.js, and the entry would be on the parse command, where we are actually parsing the whole RESP based thingy. We are parsing it and extracting commands and or sorry, one single command and args based on the different command types. And we do have exporting the next separate execute command, where we are actually executing the command by having a separate command handler as a separate entity, so that it's isolated, and later we can actually pull in and keep it as a separate file, all in all. Yeah, so yeah, so if the handler is not valid, then we're just returning it as an unknown command. If that is the if it is valid, then based on the each respective set, get, and delete, expire, we are handling the data accordingly. Yeah, and you got an exposure on how the RESP protocol works, and like the string patterns, serializing and also deserializing. Okay, I guess that's all. Just to have it in place as a consistent way, like we do, what we can do in the code down the line, will be saving the information to DB and all that, right? So we can have a placeholder init function, just so that we'll call this before, like the moment the server starts, right? So now what we can do, we can just have an init function. For now, it's all in memory, so this acts as a placeholder, but down the line we'll be having different persistent modes, like the snapshot and the AOF and append-only file mechanism. So we'll just have this as a placeholder and export this one, and in the server.js we can just call it as init. Okay, npm start. So if you see, persistence mode in memory and server running, that's fine. So clear. And I see there is a small kind of typo, I believe. I think we did cover as is in the previous video also. This literally doesn't make sense. This is not a logger.log. Maybe we can just rename this to info. That makes more sense, and I think all the necessary changes also happen. Logger.log. Okay, server.js logger.info. Yeah, it did change. Oh yeah, here also we can just logger.info. Okay, I hope we are not using console log anymore, just accept the actual logger. Okay, cool. Looks good. So that's it. That's a wrap. We can just start the server one more time and run it again. Npm run test. Okay, all 5 tests passed, and we completed all the we completed the 4 basic commands: set, get, delete, and expire. I hope everything is clear. We'll be covering TTL, increment, and decrement commands. Let's get started. Let's start by restructuring the files and folders over here by creating source folder and also test folder. So dot test goes to test, then code.js logger server utils all goes to source. Okay, now again inside source, let's create utils. Okay. What we can do, we can rename this to index. Yes. Then again, utils move. Yes. And logger.js also to yes. So it's asking for updating whether to update the imports or not. So I think this looks better, right? And package.json, let's update over here also. Source.server.js and test.server.test.js. Okay, let's start. There could be some issues. Nope, all looks good, perfect. Server.ts also should be fine. But what we'll do, as we restructure the folders and all right, like the creating files in the, I mean, moving the files into proper structure. Now we'll just try to close the loop by, I mean, we'll just try to check whether everything is working fine. Npm test. Okay, all tests passed. Looks good. Okay, now we'll start by adding test cases like for all the three commands TTL, increment and decrement. Then we'll actually write the code. So it's like a proper TTL, right? So we'll begin with having a code for TTL. So this is it. Let me just see if I can minify all. Okay, so should return correct TTL for a key and cover error cases also. So TTL is like time to live, right? So let's say if you are expiring some key, right, expire foo exp for 1 second, so after that it will be done. So let's say if I set some set expiration for a key which is like 10 seconds, so during this 10 seconds, let's say at fifth second, if you do TTL for that key, you will get as 5 seconds, like the remaining time for that key to expire. That's it. Okay, so should return correct TTL for a key and error cases. So in order to do that, so what we'll do, we'll first set a key, right? So set foo capital T and the value is exp capital T. Then expire. So what will after setting a key, I'm expiring for 5 seconds, right? So I'm just setting okay, telling to Redis stating that expire this key foo T after 5 seconds, right? So immediately what I'm doing, I'm just technically waiting for 2 seconds, right? After 2 seconds, again set timeout. So once it's done, I'm just querying it as ttl footy, so it should give 3 seconds or 2 seconds, right? Because you know set timeout is exactly not exactly as like 2 seconds, and also there will be a milliseconds difference here and there. So if you see here, the small query, what I'm doing is I'm just using get ttl footy, okay, and based on the simple regular expression for the response, right, I'm just extracting the value and I'm just checking TTL value because this is purely on the string pattern, right? So what I'm doing, once I get the response, I'll basically add a log and show you that also once we close the loop. So in a match, we're extracting the number, passing it because that would be in string, and I'm just checking whether that is like less than or equals to 3, because there is a case sometimes it can be 2 or it can be 3 also. So less than or equals to 3, and I'm marking that as a, so this is like a assert. Okay, is like this is like a boolean. If it is false, then it will throw this error, right? If it is all okay, then it's like nothing to highlight or something like that. Okay, so then in the error response also, so just to cover the other case, like I'm just passing the TTL command, but I'm not giving any sort of key for it, right? To which TTL, like for which key it should check for the TTL, right? Okay, perfect. Now let's add code to it for the TTL logic. Okay, code.js. And as for the command handlers, right, if you see, we don't need to change anything over here because this thing works exactly because the command, right, it will like look for the command handlers, and if it is not there, we actually pass for the generic unknown command. So we just need to add an extra function inside this command handlers. That's it. We don't need to change anything apart from that, right? So let's add this one, ttl, same signature actually, arcs, and as usual we'll begin by validating the arcs length. Okay, so if you see, observe, like whenever I change, the server is automatically starting. So earlier there was an issue, right? And if I just save it, it just starts. Okay, it's all with the watch. Now what we will do, we will having some logic. I'm just adding that code over here. That simple logic is I'm extracting the key, simple. And if the key is not present in the store, then there's no point in actually checking, because there are like three checks, right? First the key should be there, then the key should be in an expired state, then only you can tell, okay, how long after how much time this specific key will be expired, right? So first validation whether key is actually there. If it is not there, we are returning it as -2. Okay, this is like a standard as per the Redis protocol and the response structure. And for the expiration times, I'm just first checking whether it's part of the expiration times or not, right? If it is not there, then there is no point, because we can't extract how long after that the key would be expired. So I'm just setting it as -1 as like invalid key as part of the TTL, right? Now if you see, the next logic is simple. So first I'm getting the expiration times dot key, that will be in the timestamp, like the Unix timestamp. So date dot now, then doing that by 1000, then I'll get the actual difference. So what I'm doing in seconds, right, in milliseconds overall. So I'm getting the difference, right, and I'm doing by 1000, and that will get in seconds. So how long, in how many seconds basically. So what I'm checking again is, if you are already queried, like if you are trying to look at the already expired key, right, the expiration is like 10 o'clock, but you are looking at 10:05 or something, then the TTL value would be of course minus, right? So what I'm doing, if the TTL is greater than 0, then just give the value, that's it. Okay, so colon that specific number, right? If that is not the case, we are just returning with the same thingy, which is indirectly store key won't be there, but you got the crux, right? So that's how it is. I'll just walk through on the code again. Two validations: one, the key should be definitely there as part of the in the store, right? We are checking that. Then the second level of check is that key also should be part of the expiration times object. If it is not there, -1. So if it is there, then I'm just checking the current timestamp, like the expiration timestamp value with the current timestamp, that I'll get in the unique timestamp format. Then I'm just converting that to seconds, that TTL. So TTL can be minus if the key is already expired, right? So that will be in minus. So if it is not the case, if TTL is greater than 0, just return the TTL value in seconds. Otherwise, just the same response as if the key is not there, that will be again, it's the same thing, right? So that's it. So the code is there ready. Now let's run the test cases. Okay, there you go. Should return correct TTL for a key and error cases. Now to understand the pattern on how the response would be for the TTL, let's just add the console.log get response. I mean, it's clear on the code.js stating that, okay, this is the pattern, right? Colon so and so and /r/n. But let's just try to run it over here again. Npm test. Okay, test pass 6. So this is how the pattern is, and next line also /r/n. So this simple regular expression will extract the number from this pattern. That pattern is like colon the actual number /r/n also. So starting with colon and ending with /r/n, and also in between colon and /r/n. Whatever the number, it will extract. And as it's a string, I'm just passing it. And after passing, I'm just checking whether it's like less than or equals to 3. Clear? Okay, let's move on to increment test case. Alright, so should increment a key and some error cases also. So first I'm setting a key foo I with value 5. Okay, now I'm calling increment foo I response, and the value should be 6. Okay, then again I'm just checking with the get foo, the same command, just to see, okay, what is the value. So 6. Okay, then increment as a response to without any key, this is for an error case, and I will get this error. Okay, then again set foo invalid I as a key, tada1 as a value. Okay, now when I'm trying to increment, okay, so this will set properly, right? Now when I'm trying to increment, this is not a valid number to increment, right? It's just basically a string, so it will give us the response stating that value is not an integer or out of range. Simple. Okay, this is exactly again same as referencing to the Redis response way. Okay, so now let's complete the increment code. So we'll start with the increment, the same structure, and also regular validation, argument length, wrong number of arguments for increment. Like if we are not getting, if you are not passing any um, valid key here, so we are trying to fulfill this specific test case. Okay, assertion basically. All right, now heading on, I'll just add these blocks. If you can see, key again extracting from the args, and we are first checking if the key is not there. If it is not there, so in general what's happening is increment also can create the key, like if it's not there, so and it will return it as 1 because the value we are setting it as 1, so for the very first initialization. So without any key we can basically set and initialize with 1 with increment command. Yeah, so that's all on this one. Then the other cases is, I'll just complete the last blocks which are like validating if it is already there in the store. So this thing is, if it's not there, then we'll initialize with the value 1 and return that as a response. If it is there, we'll actually parse the value which is already there in the store, like store.key of dot value, and with the base as 10 we'll get the value, right? So if the value is not there, or if the type is not string, or sorry, if the type is not integer, any of the data type, then we'll get is not a number. And if that is the case, we are just returning with this one. And we do have like value is not an integer or out of range, we have that test case as well, this one as a last test case. Okay, if the value is like, if the value which is there, it is parsable to int, right, then I'm just incrementing that and again setting as string only. Okay, dot value. Then this is to maintain consistency, but down the line if you want to really improve, then we can just treat that as a number one. But the problem is to maintain it as consistent and like ease flow of the whole thing, I think it's better to follow this pattern, like increment then assign the value as string only, so that it's always as a string, right, as a generic way. Okay, then I'm just passing that as a same thing over here. That's it. So the incremented value, I can just use this one, but up to you, should not be a problem. It's one operation, so if you want to really save that extra math operation, you can just do this one, and it's again a lookup inside a key, so up to you. Clear? So let's run the test cases again. This time around the test cases should pass. Perfect, so increment is also done. Now let's add test cases for decrement. Okay, set foo d and the value is 11. Okay, now I'm decrementing and the expected value should be 10. Okay, then again I'm just using the same get command to assert the same value whether it's coming or not. Then response to, if you see decrement without any argument, then I should expect wrong number of arguments for decrement command. Okay, then set foo invalidate to, here if you see this is like a string, when I'm trying to decrement I'll get this error, value is not an integer or out of range. Clear? Let's save this one and let's complete the actual code. decr args, it will be a almost similar, so let me just add the arguments validation, self-explanatory. Then the same thing, like if the key is already not there, then setting that to -1. So assume that okay, there is a value as a 0 if the key is not there, right? So when you are calling increment, the response will be 1. If you call the decrement, so initial value assuming it as 0, then if you decrement, then it will be -1. So even if the key is not there, same as increment, for the decrement if the key is not there, we'll return that as a -1 assuming it as 0, so -1. That's it. Okay, then let's complete the loop for the actual code. Oops, decrement. That's it. Okay, so it was saved. I mean, it's the same. Like if you see, once the value we are getting passing, not integer, return the error. If it is the case, return value -1. That's it. So let's run the npm test. Now the decrement also should be working fine. Clear? Understood? Now, as a small extra thingy, I don't know why I didn't cover, but that's a valid case, is I'll just do this one. Maybe the posture scenario, let's do this one. Okay. Oh, sorry, increment thingy, this one. Oops. Another recession to complete the case where the key is not there, but we should get value as 1, right? So response 2, oh, it's already there. Oops. So response 3, maybe we'll just reorder this one and keep it at the very end over here. Okay. Okay, so I will give something which is not there. So set foo increment, increment foo, something like this, new key. Okay, and the value should be 1. Okay, let's copy response 3 over here. Let's copy the same block, have it here. This should be DCR foo new key 2. Let's this as 1. Okay, foo new key 2, and this should be -1. That's it. Okay, let's just reset the server. Now let's run the test cases, and it should work for this decrement and increment also. Okay, test 8 all passed. This assertion is also correct. So for the decrement, if the new key it's not there, it will be -1, and for the increment, for the new key, it will be +1. We'll be covering 5 operations on list. Let's get started. We'll begin by adding a test case on L range, and that too this is not a functional test case. It is kind of a error scenarios and also kind of a validation scenarios test case. So if you look at the pattern, should return error for L range invalid key. So what exactly is L range? L range is nothing but will mention a key which is kind of a list based data structure, and list is, again you can treat that as an array, and we need to pass the starting and ending arguments, like both are inclusive again. So if we pass, let's say if we have a list of 10 elements, and if we pass 0 to 5, then we'll overall we'll get 6 elements. So start and end index is like inclusive, and index starts with 0. That's all on the list. So how exactly we can pass and all? So if you look at the pattern, so I'm just calling L range list 1. So if you see wrong number of arguments for L range, reason we need to pass starting and ending like this. So if you look at the second command, L range list 1 0 and 4, and the reason it is giving -1 because this list 1 it's not there in the Redis itself. So if we just give some random key, then in that case it will just return -1. So this is kind of a validation and error case scenario just to check. Okay, now let's focus on the actual function lpush. Lpush is nothing but pushing elements into the list from leftmost to the rightmost. So left push, you can remember like that, lpush leftmost, so left push, right? So if you see here, lpush list 1 and the element is el1, and if you see here, we didn't actually declare any list here. So Redis will take care of it. If the key, if we are trying to push L push, like we are doing an L push operation on list 1, and if the key doesn't exist, it will create a list with list 1 as a key, and also it will insert EL1 on the left side of it. Now we just passed one command, lpush list 1 and EL1. Now the following command, if you see here, lrange list 1, and I'm asking just to give me the first element in the list, 0, and the ending also is 0. So we'll total get 1 element. And if you see, the expected behavior is again the same thing. So 1, the length of the array, right? So lrange should, the return type should be a list, right? Array you can treat. So 1 is nothing but it is returning only 1 element because 0 0 as an expected behavior. So and $3 is nothing but the number of characters in that list value. So el1 3 characters. Got it? Now if you look at the next command, lpush foo, we're just passing lpush and foo. We are not giving the actual element where that element needs to be pushed into this foo. So we'll get wrong number of arguments for lpush command. And if you see here, lpush foo 1. So if you see here, set foo bar. So I'm just creating a key foo with value as bar, which is not a list again, right? So for a non-list based key, right, if you try to push, we will again get this error, like wrong type of key. I hope these two test cases are clear. Now let's jump back to the actual code and we'll start with the lpush functionality. And the first validation is number of args. We need minimum 2, of course, so that the key and the second argument would be the element. And I'm extracting the key, and I can pass in the left push again, I can pass n number of values, so that all these elements will be left pushed into the list, that is into this key of list. Yeah, so first I'm checking if this already we have a list, or at least the value with this key in our store. If it is not there, then I'm just creating an object again with the same pattern, type list this time, and the value is an empty array. Clear? And if you can see here, for the normal string base, type string and the value -1. Okay, value is -1 here. It's a case where for decrement, but if you see normally also, like increment, TTL, and even for set, type string and the actual value will be the same value as value. Yeah? Then on to the extracting the values from the argument. So first argument would be the key, and all the values after the key are the actual values, so that these values can be inserted into the list, like pushed onto the list. Yeah, and this if block is self-explanatory. As you can see, if this key is not present in the store, I'm just creating that, initializing with the type list and also the value as empty array. Okay, then let's say if it is there, right, and I'm just checking the type list. If it is not there, then we'll get wrong type of key, okay, as an error. Like as you can see here, we covered this case as well, like at the last, set foo bar, so it will create the type as string. Then we are trying to push an element 1 to the foo, which will get wrong type of key. Okay, then unshift in JavaScript is basically pushing all the values to from the left side. So from 0 value, it keeps pushing onto the thing. So value dot push in general, like array dot push is like adding all the elements at the right side, but unshift is like opposite. We'll just adding elements to the array from the left side. Simple. So unshift. And if you can see here, the most important, the return type, store key dot value dot length. So it will return the value, like the number of elements in the list. Okay, that's it. As simple, right? So we are just doing the validation on the arguments, and we are just initializing if it is not there, type check, and we are just doing unshift from the JavaScript, and we are returning the value like the list length. Clear? Now let's complete the lrange function. Again, in the lrange we need definitely 3 arguments: the actual key, like the list key, then starting and ending index. So that's why we are just checking the args length, and if that is not the case, then no, wrong number of arguments. Then the first argument would be key, of course, the same pattern, start and stop. That's it. So first I'm checking check expiry, the same thing as similar to the get request, like similar to the get command. And in this specific case, we're just checking whether the type is also not list. If that is not the case, then we're just returning -1 if it is not the list, and if it's not there, and all that stuff. Lrange, right? Lpush, if it is not there, we'll try to create an array like the list and push the elements. But when we are querying lrange, the key should be there, and the key also should be of type list. Then only we should return the actual elements based on the starting and ending index, right, inclusive again. So if it is not the case, we are returning -1. So now for the actual retrieving, well, like all the validations are done before, right? So now first we'll get the list, right, store of key dot value list, then start and stop indexes. Now the most important line, list dot slice. If you see here, the actual definition of slice is in JavaScript is basically it will give you the shallow copy of this list array, starting index and the ending index. And in JavaScript definition, here the ending index is not inclusive, but in the Redis, the starting index and the ending index both are inclusive. So that's why we're just adding +1 over here, simple, and it will return you the shallow copy of the list. Then on the return type, if you see, we need to begin with server.test. If you look at the pattern over here, L range 1. So 1 here is nothing but the actual length of the range. Like if you are if this thing resolves to, like, let's say 3 elements in the range out of 5 as an example, then the range dot length value will be 3, right? Then for each value, like for each element in the resolved range, the same pattern, length of the value and the actual length. Yeah, that's it. Simple, right? Now let's try to run. Let's use version 22. Okay, npm start. Okay, server is running. Now let's open another console over here, then npm run test. It's testing all the cases, and if you see here, lrange and lpush test cases are also successfully passing. Yeah, that's it. Now let's cover the rest of the 3 commands on list. That would be rpush. Let me just minify quickly. Okay, so we covered this till here, lpush. Now we are covering rpush. You got the drill. It's the same thing, just exactly opposite to the lpush. That would be, we're pushing elements on to the right side of the array, not to the left side. That's it. Same fashion, rpush list to el. And so in this case, I'm trying to push el to this key list2 of type list onto the right side of it, right? And after that, I'm just checking, I'm just getting the first value, and that should be el, the one what I pushed over here on the previous command, right? And the next command would be rpush list2. This is for the number of arguments. Then again the same thing, wrong type of key if we are trying to push to the string type of value. Now let's cover lpop. Lpop is, if you look at the first test case, lpop list3. That's it. So it's not similar to the push commands, because in lpop we are trying to actually look at the valid list3, valid key of type list, and pull the element from the leftmost side of the list. If it is not valid, then we should return -1. And I'm pushing 2 elements, list3 el1 el2. Then on the L range, I'm just validating 0 and 1 whether I'm getting 2 elements. And if you see, the array length is 2, the first element character is 3, and the second element characters, number of characters are also 3. So this is the pattern. And if I call lpop list3, now el1 should be removed. Oh, sorry, el2 should be removed, because first el1 will be inserted, then el2 will be pushed from the left side. So after this line in list3, the first element would be el2, then the second element would be el1. Now when you query lrange also, first it will give you el2 and then next el1. Now if you call lpop list3, it should return el2, because this is the leftmost element in the list. That's it. So we are validating the same and the number of characters. Okay, then without any arguments, the same number of arguments, same validation. That's it. rpop, self-explanatory again, similar fashion. So rpop list4 -1, because list4, it's never declared with the type list, and it's not even there in the first place. Then I'm pushing some elements, then I'm validating again. Then on the rpop list4, if you see here at this stage, right at this line, the list4 has el2 and el1. When I do rpop, the result should be el1, because this is the rightmost element in the list. Number of arguments, validation. That's it. Simple. Now let's complete the actual functionality for the rpush. Let me hide the sidebar. Rpush, same thing, arguments length check. And if you see, using the spread operator to get the rest of the values, like the rest operator technically, yeah, key and store of key. If it is not there, initialize the same thing, and if it is not type list, throw this error and push. So our push is nothing but the literal push in the JavaScript, so we are just pushing into the array. That's it. And we are just returning the total number of elements count in the list. That's it. Now let's cover lpop. Slight change on the variation, but if you look at the pattern, number of uh, arguments, one is enough because we just need a list key, lpop list key, and it will just remove the element from the leftmost side on the list, in the list. That's it. Okay, so just the key expiry, some the same existence key validations if it is not there or if it is not type list, and if the length is 0, then it can't return anything, so -1 for all these cases. Okay, then if the value is there, like if the value sorry, if the array length is more than 1 and if everything is valid, like store of key, then I'm just using shift again. In JavaScript, it will just remove the element from the first index in the array. That's it. And once it's done, value dot length, returning the actual value. Now the final command, rpop, for the whole functionality. In the next videos, we'll be focusing on how to persistently improve on the persistence, like store in the append-only file mechanism and also as a snapshot mechanism. So this is the last command as part of our whole course. So rpop, same thing as lpop, right? Just that the element will be removed from the right side of the array. The same validations and value loading, and this pop is nothing but the rpop in Redis is nothing but the exact functionality as pop in the JavaScript. That's it. Okay, value dot length, value. That's it. So let me just reiterate. Lpop, we should remove the element from the 0 index in the array in JavaScript, so we'll be calling shift function, and the normal regular function pop for the rpop mechanism. That's it. So let's restart. It should be starting, but any which, yeah, it's keep restarting when we save the file. Okay, now let's run the test cases again. npm run test. Okay, all tests passed. rpush, lpop, rpop. We'll be covering adding data persistence with snapshots. So snapshots is like one of the persistence mode. Then the second persistence mode is append-only file, that we'll be covering in the next video. So yeah, let's get started. We'll begin by adding a simple config.json file, and inside that we will start with snapshot as true, and also snapshot interval, like how frequent we should store the snapshot. Okay, to begin with, we'll just start with 5000 milliseconds, so that would be 5 seconds. That's it. Okay, so if the user wants to change this one, and he can disable that, and I'll basically give a walkthrough of that also by testing in memory persistence mode and also the snapshot mode. Next, we'll create persistence.js file. So this file will take care of storing everything, like even for the next video, that is like append-only file, this file will be responsible for storing and retrieving also. And the initial modules we required is file system fs from the node, promises version of it, and also the path. And I'm creating an instance with the logger, and again, if you see, persistence as the namespace. Okay, next we'll create the persistence class, and we can also export this as new instance, kind of a singleton. Okay, now we'll have a property data file, and that will give you the basically the path for where exactly we need to state the snapshot. Okay, and that I'm naming it as data.rdb. Okay, now we'll have the constructor, and inside we'll store and expiration times as an empty objects. And if you can recollect, in the code.js we are storing here globally, so these will be removed and that will be loaded from the persistence class itself. Okay, now we'll start with save snapshot function. All right, and this is kind of an async await we'll be using, and we'll be explicitly having a sync function also that I'll come in the later stage of the video. So in the save snapshot, we'll be having json.stringify the same values, this dot store and also the expiration time, and that will be purely in the data file, and that object, sorry, data object itself, and that object will be directly saving inside the data file location and the exact data json.stringify. We are not formatting it with a proper two tabs or like one tab. We're just storing it as a raw format because long term the file would be like not kind of a user friendly to read, but again that's not the purpose of storing that in a data.rdb, right? So our server, whenever we restart and in the persistence mode of a snapshot, it will just basically read that file and load everything. So it's not to read, so I think I strongly believe that it's not really necessary to format the JSON when we are storing in this data file. Okay, and if you see here fsp.write file using the promises version of file system, and I'm storing this data in this data file, that what we configured over here. Clear? And then I'm just having a log, and also if there is an error when saving, I'm just logging this also. Not throwing any error at this stage, but we can improve on that as an improvement part, but that's it. So save snapshot, whenever we call save snapshot function, it just stringifies the whole these two objects, store and expiration times, and that would be inside the data object, and that will be as is saved into this data file. That's it. Now that we have completed save snapshot function, let's start by writing load snapshot. And if you see here sync, the reason I went with the not the reason I didn't go with the sync approach is for me I felt like, okay, whenever the server restarts in the persistence mode of snapshot, first it should completely load the whole file and store that into the in memory, then only it can accept. But it can go the other way also. We can still start accepting, and if you can see here, store expiration times, anyway it is loaded with an empty object, and in the load snapshot we'll be merging the values, so should be fine. But I just still felt that it is safe to first load the entire snapshot file, then we can start accepting, but it can go in any way, but our server can do in both ways. So next, in the snapshot, the first validation is if the data file exists, then the actual code, it's wrapped with a try catch, and if you see here, first read file sync data file to string, that's it. So if data exists, then I'm extracting store and expiration times by having the json.parse, that's it, and the named variables loaded store and loaded expiration times, and I'm merging, that's it. Okay, so this dot store and this dot expiration times will be having the latest information whatever it is there in the data underscore file, that's it. Once it's there, I'm adding a logger if at all there is a error, and just logging again. So you can challenge me stating that why don't we crash the server or something, or at least throw this error and stop the server gracefully, or let the user know, like wherever whoever is running the server, we can do that. But overall, as you can see, the data can be still stored in memory, and we can keep calling the save snapshot, and it can keep overwriting the value, so should be fine. But the crux what I felt is like we can just gracefully do it, like add a log message, but again anyway this save snapshot will be keep saving with this interval, snapshot interval. So I felt like we can do in this way just as a graceful, but it's a um, basic project where this will create a base for you. From there you can make it as robust as possible, but you got the crux right, so that's more important. That's it. Load snapshot sync, simple. So to sum it up, persistence class, two variables, store and expiration times. Save snapshot, get the in-memory store these values, save it in the JSON format as a stringified version, and just store it in a file. That's it. Load snapshot, read the file, like if it is not, if it doesn't exist, just ignore. If it exists and if the data is there, then we'll try to parse it and extract store and expiration times and merge with the in-memory this dot store and this dot expiration times. Simple. Okay, now that we have completed persistence, now let's move on to core. And if you can see, store and expiration times not really needed here because we'll be loading from the persistence itself, so you can just remove this. And first we needed config. The reason in the initialization, remember init, here we'll be actually having this logic where how frequent the file should be saved, and also on the first time it should load the snapshot also. So config I'm just importing over here, and persistence instance singleton, and store and expiration times, right? So once these two came, right, rest all the code we really don't need to touch. Now that we'll just close the loop by completing the function definition of init. So first we'll cross check if config.snapshot is set. Okay, else we can just simply ignore this one. We can wrap this over here. That's it. Okay, if config.snapshot is set properly, then what we can do, we can just simply add a log stating persistence mode snapshot, as in the else condition. If it is not snapshot in memory, this is already there, right? So if it is snapshot, I'm just adding a log, and if you can clearly see here, persistence dot load snapshot sync. That's it. So this function will be executed, and all the values will be merge this dot store and this dot expiration times. Clear? Now this is like whenever the server started in the snapshot mode as a persistence mode as snapshot, right? Now we will use set interval to store the snapshot every time, like the with the frequency of whatever it is set here. Okay, so inside the core set interval async await, again same logic, persistence save snapshot. That's it. So every time, so here if you see here, now it's 5 seconds, so every 5 seconds this function will be called, and what are the values stored here, this dot store and this dot expiration times will be saved into the flat file. That's it. This is a very basic thingy. There can be so many edge cases and all, but this will give you the base, so that from there you can actually improve and make it more optimized. That's all. That's all the changes required for the persistence mode of snapshot. Now that we have completed the whole loop for the persistence mode of snapshot, let's start the server. Right? And if you can see here, persistence mode snapshot. Now every 5 seconds it will store. So if you see here, 14 and 19 second, save data store to file so and so data.rdb. So if you look at the data.rdb file, it's all empty because every 5 seconds it keeps overwriting, but we haven't done anything, we didn't do any command. So what we can do, we'll just expand, split the terminal, and maybe we can actually start the Redis CLI instead of test cases. Test cases also we will cover, but let's begin by just simply having this one. So set bar, the moment, luckily it just happened at the time, let me just do it again. So set Bharata. Okay, save. So we got this command, and now it's not there, but after 5th second, if you see here, key Vivek, type string, again the value, and value is Bharata. That's it. This also, this we got an acknowledgement, and after, see, the value removed. That's it. It's clear, right? We can actually do run the test cases end to end, so that you can see so much of all the different test cases values and all. But yeah, all tests passed, and if you see here, all the test cases what we have done across the whole thing, right? So all the information is stored. Now it's stored, right? Now let's completely stop the server. Okay, now we'll do this activity. So now in the data.rdb you can clearly see that we have a foo key, right? And if you just go down, we have foo d also, and maybe we'll use the l range. Okay, list 3 is there, right? List 3, it's only element 1, maybe we'll use, I think should be fine, just to make sure that everything is working fine, like the loading of snapshot also. So npm start, data stored loaded successfully, as you can see here. Okay, now we'll again connect via redis CLI, and let's call lrange list1, oops, 00, let's try to get the first value, el1. So it's all working fine. Clear? So persistence mode is simple, just try to save everything into the JSON format in the RDB, and whenever the server restarts, we'll try to load that file as a sync in my way, but we can do it as an async also. We'll be covering append-only file persistence mode. Let's get started. To begin with, we'll add an entry in the git ignore file, that is source star.rdb, so it will basically skip any RDB files. And also will be from now on we'll be having a persistence mode of AOF also, append-only file, so we'll just add that also as part of the git ignore. And in config.json we'll start accepting another configuration parameter, that is append-only. Simple, that would be true in our case, and we'll just ignore false. Like, we for the snapshot we are making it as false, so that from this point the server runs with the append-only mechanism. Then moving on to config.json, we'll actually start consuming append-only, like new parameter configuration, like which persistence, again append-only true, so that we can skip, like we can omit snapshot. So from this point the server runs in append-only persistence mode. So now if you can think of in code.js, in the Mify, and in code.js init, we should be consuming that also, and accordingly just add that specific if block, and that if block would be config dot append only, right? For now I'm just printing, so persistence mode append only, that's it. Now onto the persistence.js file, we'll be adding two more functions that would be similar to the save and load for the append only. So to begin with, we'll have append AOF as async operation, the same command and args, exactly what we call it in execute command and args. So we'll basically complete the loop over here. So once we execute the command, we'll pass it down the same arguments to append only file, so that it just appends to the AOF file, that's it. Now we'll construct the append only file log line, so that would be simple as command space separator args, and again we are just joining because args is an array type. Okay, then later if you see, simple try catch fsp append file AOF file, right? So AOF file, I think we missed to add this over here, so let's add that also. So we can just do a path.join, and or we can just simply use, okay, what exactly we added over here. So yeah, so we can do data.aof, that's it. Okay, so now append AOF, this function will be called for every command in the execute command, where like this is the, like where the actual command executes on the server, right? And also in memory stores and all. Now this function will be called inside the execute command, right, in the code.js, like once the actual request is processed, and we need to basically simply call this function, that's it. Now we'll just try to wrap the other file also, that is like replaying of AOF. This is like simply as loading snapshot things, similar to the thing. So in the load snapshot we are loading everything from the file and loading into the in memory, right? Something similar in the replay AOF file, replay AOF function, basically we'll just read the AOF file again and rerun the same execute commands onto the actual server, so that all the data, whatever it is there from the beginning, it gets loaded into the server. Now we'll begin with by writing a replay AOF sync function. Again, if you see here, it's sync because we should make sure that the whole data is read and loaded into the server, then only we can accept requests, right? So replay AOF sync, then the first validation would be simply as first the append only file is there or not, right? First the append only itself is configured, and if that is the case, then the file should be there, otherwise we'll just return. Okay, then it's starting with a simple try catch, right? And the first thing is, first we're reading the whole file and converting into string. You can challenge me, this is kind of a vague approach, because of course this is like a POC sort of thing, right? So in this mini project we are just using read file sync, but what exactly you can do, you can actually read it, open it as a stream and read line by line, and accordingly you can split the commands and arguments and just directly execute the same command again. You got the crux, right? So for the sake of our mini course, I'm just using read file sync, but the best practice is always to use file stream, right? Okay, so then moving on to the, so once we, if you see here, once data is there, I'm just splitting up with the next line, right? And I'm just filtering, okay, we get a proper logs. Then after that, if you see, I'm just iterating on that logs, log entry. First one in the array would be obviously the command, and all the rest of the uh, elements are arguments, okay? So by splitting with the space. So once it's done, I'm just simply calling execute command. If you notice, there is one small an extra parameter we are passing over here. It is true. I'll just come to that soon. So that's it. So once we iterate for each log entry and we are doing execute command, that's it. Simple. So replay AOF sync function will make sure whether the configuration is append only and the correct AOF path is there. Then we'll try to read file sync instead of read stream, but that's the best practice to use read stream. And later, if data is not there, then just simply return. Else, split the new line with and filter with a boolean just to make sure everything is intact, like not to consider empty lines also, right? And later logger.info, I'm just adding a log and log entry, iterating on each logs and command arguments executing. So this execute command, if you see, it's kind of a call, not kind of, it's a callback function. We're just passing the function over here, right? So that is called actually over here inside. So I'll just show you how this is works when we try to complete the loop in code.js. Yeah. So once it's done, replay AOF successfully completed. So all these things will happen when you immediately start the server. Also config, I guess we didn't import it, so let's just import that also. And let's move. Okay, I think this is the right correct place. Okay, that's it. Now let's jump back to code.js. Over here in execute, we'll accept another argument with default value as false, right? And I think we can just simply replace this line, this logger line, with this line. So it will tell you whether it is running in the replaying from AOF or not. So if you can think of it, by default execute command will just pass command and args, and this will be false. Okay, if at all, like if the execute command is actually triggered from the replay AOF function, right, then we'll pass the value third argument as true over here. Okay, clear? So then code.js execute command. Now instead of directly returning handler of args like the result of handler function, we'll just first save it in result. All right, then if you see, we are just having an if condition, checking if the configuration is append only and if it is not replaying from AOF. The reason, if you don't pass this argument, right, it just basically reruns the same thing, right? It reads from the AOF and keeps adding to the AOF again. That doesn't make sense. So we should explicitly say that, okay, this execute command, whatever this command is being executed, this is from the actual request or from the replaying from AOF in entry point. Yeah, so that's why we'll make sure that replaying from AOF is actually false. Then only we should actually save that to the AOF. Otherwise it just the same duplicate keeps appending to the AOF file. Okay, so if you see here append only, then replaying from AOF not, then AOF commands list. So if you see here, the Redis server will accept all read and write operations, but if you think through append only file, it's only needed for all the write operations, right? So what we'll do, we'll just have a set of commands. Now if you can see, these are all the write commands currently we are supporting: set, delete, expire, and so on. Okay, now switching back to code.js, so we are validating, do it only for the commands which are write operation and save it, and we are just passing the command and args and just saving. That's it. That's all for the append only file persistence mode. Let's delete data.rdb, which is not required, and just to clear the stuff, and let's run. Let's see, npm start. Okay, persistence mode append only. All right, and the file also, it's not there right now. We can just leverage our tests, so npm run test, simple. Okay, so it will basically do all the other operation, all the basic operations, right? So now once it's done, if you can see data.aof, and the order of commands, if you can see, that will be exactly same as how we are configured in the test file. Okay, so if you see set foo bar, set foo del pool bar, and on and so on, right? Now the fun part. So I think this is done. Now if you can see in the logs for all the writes, right, we'll just having a supporting log. Like if you see here, received rpop and received lpush, and the following subsequent, if you see, appended to AOF file rpop list 4. And if you can clearly see, for lrange we are not doing anything. Clear? Now if you start again, all the data from the data.af should re-execute onto the server. Okay, looks like it's missing. Oh yeah, of course, in the code.js we just added a log, but we didn't complete the loop of replaying, right? We'll just add this simple line, persistence replay async, and we are just passing the same execute command. So we are just passing over here. Simple. Okay. And if you, okay, as soon as I saved it, I just started, but let me just clearly show you once again. Delete this file. All right, clear this out. npm start. There's no file. We are not running anything over here. Now let's run the test cases again. Then data.af should keep loading with all the commands what we ran, and then later I can show you like only writes, right? I mean, what we configured over here, these only these commands will be saved into the data.af. Okay, now I'll just stop the server and start it again. And if you can see, all the logs came, persistence mode, replay AOF started, and if you see true, this is nothing but it is loading from the all these commands are executed with the AOF replay, not with the actual commands, right? This is just for the pattern. I think this is vague, but we can improve on this as well. So replay AOF successfully completed, and I guess else is missed, but of course it does work because it's like a normal simple if condition separately, but else if is the correct way. Alright, so that's pretty much it. To sum it up, on the init function, we are consuming append-only configuration also. If that is the case, we are just calling this one. This will basically read up the file, convert to string, split widths in next line, filter it out with empty lines. And once we extract command and args, we are just passing, and this is very important, execute command. If we mesh this, then the duplicates will keep on adding to the AOF, and it's purely kind of a recursive, not recursive, but again it's kind of like, let's say if you run it for once, and if you don't pass this one, then for the second iteration it will be 2, and for the third iteration it will be 4, so it will be like exponential, right? And it's a blunder also, so we should, this flag is very important. And append AOF is simple, like as soon as we get the command, we are just appending to the file. We'll cover the project recap and also future improvements. Starting with the course recap, we actually started by setting up the basic development environment and also tweaked around the basic TCP server, how the TCP server works and how we can interact, and also Redis basics and very basic TDD initialization also, so that will create a base to cover for all the rest of the chapters. And on chapter 3, we basically completed the loop of client connection so that we can actually connect from the actual Redis CLI, not even using some mock and all. We are using in the TDD initialization, we are actually connecting again with the TCP server. But overall, to test the very basic commands like set, get, delete, and expire, we actually played around by directly connecting to our Redis-like server from the actual Redis CLI, right? And in chapter 4, we completed the other three commands, that is TTL, increment, and decrement. And in chapter 5, we covered all the 5 operations on lists. And in chapter 6, we actually started working on the data persistence. And in chapter 6, we covered the one of the persistence mode, that is snapshots, RDB. And in chapter 7, we completed second persistence mode, that is append-only file. And I given a walkthrough of how we can actually complete the append-only file mechanism for data persistence for our Redis-like server. Yeah, that's all for the whole course recap. And moving on to improvements, again, I just want to highlight, yes, I agree. Node.js is not the actual, or at least let's talk in language perspective than JavaScript. JavaScript is not actually meant to write a Redis-like server, but for all the JavaScript devs, this course will give an opportunity for you to understand how the Redis internally can work and what are the underlying architecture, what is the data patterns we can follow to cover all the basic Redis functionality, right? So this is just to leverage the JavaScript so that all the JS devs can understand how Redis can work internally, right? So on to the improvements. As you can see, we can actually add the authentication and authorization layer. So that's like a very first improvement we can cover. And also we can cover more data structures, like as in we have hash, set, stream, bitmap, also all these data structures actually being supported by the original Redis server, right? And also it does support bitmap, bitfield, and also geospatial. So these are like the different data structures we haven't covered because that actually sets the same path of what we did for TTL increment and also for the list, right? So we can cover different data structures what the actual Redis is supporting. And also we can cover transactions. Yes, Redis also has something similar to the SQL, where or even NoSQL with the latest Mongo version, where we can support transactions, right? So more or less it's the same functionality, where we can achieve the same thing in Redis also. Yes, officially Redis also supports transactions. The final improvement what I can think of at this stage is pubs up mechanism. Yes, it's the same thing, which can be helpful for implementing a real-time notifications or sending messages between microservices, something like that. But again, it's kind of not reliable for sending messages across microservices, but it's like a one-time thing. So you could leverage that also, but not for a production grade, I believe. But still, there are some companies using that also. So yeah, so that's all the improvements I can think of, but there are so many other, like on the architecture level, like we can introduce clusters also so that it can be improved on scalability and all. But I think confined to a one single dev, I think yes, of course one single dev can achieve a lot, but as a learning curve just to understand and all, I think this is a very base setup is enough to kickstart and cover all the other improvements as well.